why are some materials, like maybe glass or air, how's air, okay, or water, how come they're more or less transparent? Some are more transparent than others. I mean, you can see the water, you can see um, the glass in your window, so it's not completely transparent, but you can see through the glass. You can see the tree that's on the other side of the glass, okay? And others, like the brick wall that makes up your house, the cement wall, you can't see through that. How does Mother Nature distinguish? How does she do this magic trick? Here you can see through, and there you can't see through. Okay, and so for this we have to start at the beginning, and the beginning is that in this site, at least, we do not follow the mathematical method, which some people call the scientific method. We call it the mathematical method. We call it the mathematical method because all the explanations, physical interpretations, are irrational. They're not even, you can't even conceptualize them, okay? And I'm not talking about easy stuff like Jesus Christ going to heaven and coming back, that's simple stuff. That God can do that, okay? He's powerful enough. I'm talking about moving concepts. God cannot even do that. He's not that intelligent or that powerful, okay? God cannot move a concept. And that's what we have in mathematical physics. That's what the mathematical method led to. We had 400 years of the mathematical method. Okay, and so here are the issues of the different components, the main components of the mathematical method, which we do not follow here. Okay, so we have a different, since the beginning of this century, we had a paradigm shift. We have a new scientific method, and it has nothing to do with what I'm going to show in a second here. It's got to do with what? With explaining. Science is about explaining. If you cannot explain something, a mechanism in physics, right, you are not a scientist. Okay, and I don't care if you have a PhD from Harvard or Cambridge, you are not Cambridge. You are not a scientist. I don't care what degree you have, you're not a scientist. A scientist is someone who can explain something rationally. Okay, we got that? So this is what the mathematical method does, which they call the scientific method. It's been around for 400 years at least. You could say Galileo, Newton, all these folks from the 17th century started this method, and it's the mathematical / experiment method. Okay, and so we do away with that here in this site. So this is the first thing you have to understand about this site in order to follow the train of thought. Otherwise, you'll be lost, okay? And so here it is, okay? Here we have the mathematical method, observation. We don't do observation. We don't gawk, okay? Like Stevie gawking there, okay? We don't gawk, okay? The fact that you observed something doesn't mean you understood what you observed or that you can explain what you observed. So observing, just looking, staring, drooling, that does not mean that you're a scientist. Okay? So we eliminate the word observation, observer, partly because it's testimony and we do not accept testimony in science. Okay? Testimony is outlawed. That's in the legal world. In the legal world, the prosecutor says, brings a witness and says, I observed, I saw. We don't accept that in science. In science, you have to say, let us assume. You can't say, I saw God. I observed God. How did you observe God? Well, I saw the rose. It's so perfect. Who else could it be except God who created the rose, the perfection of the rose? Well, you didn't see God. You didn't observe God. Okay, but you put it in such a way like if you saw God with your own eyes and make the rose. That's the way mathematical physics works in general. Okay, they take this testimony and turn it into a fact. Okay, we don't do predictions. That's astrology. Okay. We don't do prediction. We don't say what's going to happen tomorrow or please prove your theory by predicting such and such thing. No, we don't prove theories and we do not make predictions. We explain the past. We explain consummated events. You have to explain something that happened. Okay, that's the way it works. So the fact that you can predict that tomorrow there's going to be an eclipse does not mean that your theory is correct. The reason, and again, a prediction is just a description. All you did is say, tomorrow there's going to be an eclipse at 2 o'clock. So what did you explain? You haven't explained anything yet. You haven't explained why you predicted this. But if you can explain it, it's because you're relying on experience, on the past. You had some experience with eclipses. That's why you can explain it. Explain past, predict future. We don't do predictions in science. That's religion, okay? Astrology. Okay, so we don't do predictions. Anyone using the word prediction, the word observation, we kick them out of science. Okay? Experiment, we don't do experiments. You say, Bill, what do you mean we don't do experiments in science? No, we don't do experiments in science. Sorry to misinform you, disinform you. We don't do experiments in science. What we do is explain experiments. We don't do them. We don't use our hands. Okay, we don't go to the lab and do an experiment. What we do is we go to the conference and explain how it happened. We explain the mechanism. That's what we do in science. And the only reason that the mathematicians introduce experiments is so that they can measure and present it as evidence. What do they present? They present an equation. They present the measurements. They said, here's science. I measured the table. It measures 1 meter. Here's the equation. Give me my Nobel. That's the way mathematics works. That's not what we do in science. In science, we do not measure. We do not come up with equations, which is just a description. And we do not do experiments. We have to explain the mechanism. We have to explain how this universe works. We need to know how Mother Nature does gravity. We need to know how Mother Nature does magnetism. Okay? We need to explain the mechanism Mother Nature uses. For that, there is only one way. And that way is to make the invisible objects visible. The invisible mediators. You have to make them visible. What mediates gravity? What mediates magnetism? What mediates electricity, etc., and light? You have to make visible the invisible. Okay? And those who say, well, there is nothing there. There is nothing that mediates gravity. There is nothing that mediates magnetism. One magnet attracts another, but there's nothing in between. You are, in effect, introducing black magic in your explanation. You're introducing spirits in that space. So those people who say there's nothing there because you can't see or touch it, they're religious folks. They're introducing spirits, and they're explaining with black magic. They're saying one magnet attracts another by act of magic. Nothing in between. No physical entity between the two magnets. That's what they're saying. So you have to identify, have to make visible whatever's in between two magnets. If you can't make visible what's between two magnets, you are not a physicist. You are not a scientist. I don't care what your degree is. That's the way it works in science. Okay? Measurement, we don't do description. Math is just description. Math is only a religion that does descriptions. Has nothing to do with science, mathematics. Mathematics, an equation can only describe, is only a description. Mathematics is a language, actually. Language of adverbs, quantitative adverbs, and nothing but. Okay? Mathematics is the branch of mathematics that tries to give a physical interpretation to the equation. And that's when they get into all this irrationality where they start moving concepts such as field and waves and vortices and who knows what, energy, information. They transfer information. Whoa, I got hit with information. They transfer it into my face. Okay, credentials. We don't pay attention to credentials. That's stuff that the Vatican does, I think, the Pope. They rely on authority, the authority of the Bible, of God, We don't do this. We don't care what degree you have. You can have a PhD, a master's. Doesn't matter to us. Please explain. If you cannot explain, we don't care what your degree is. Okay? So, you can't say, I got a Nobel. Well, yeah, who gave it to you? Your buddies? I mean, so you got a Nobel. What did you explain? What can you explain? Can you explain gravity, the mechanism? Can you explain magnetism? Can you explain electricity? Can you explain light? Can you explain the workings of the atom? Can you show us your atom? What does it look like? Is it this planetary thing that goes around? So again, we have a problem with people who just use authority and say, oh, but I got a PhD. Yeah, who cares? All you did was suck up. That's why you got a PhD from Cambridge or Harvard. I mean, if the guy, your supervisor, your advisor, if you didn't bow down to Einstein, I'm sure he wouldn't have given you your PhD in mathematics. Okay, so in fact, the PhD shows quite the opposite if you've got it in mathematical physics, right? If you got it in mathematical physics because you know nothing about physics, absolutely nothing. All you did was suck up. That's why you got that degree, and all you do is parrot the party line. You just memorize the catechism. You're just reciting poetry. Okay, voting, we don't vote. We don't raise our hands. We don't vote for theories. Not in science. We do that at the congregation on Sunday school. We go to Sunday school and we all vote for God and for the Bible. That's where they vote for theories. Okay, yeah, God created the universe. And so, all this voting that, hey, all the scientists on earth believe this, well, we don't care. They could all be flat earthers for all we care. It doesn't mean that their theory matches what Mother Nature does out there. Mother Nature laughs at these people if they come up and say, well, gravity is warped space-time, and a particle can be at two places at once. I don't think so. I don't think Mother Nature likes that at all. Yeah. And prizes, we don't win prizes. No beauty contests in science. They have these prizes, the Wolf Prize and the Nobel Prize. We don't give prizes in science. Okay? It's in religion where they give prizes and they certify knowledge. They say, oh, I got a medal. I have certified knowledge. Now I can trounce anyone I want because I've got authority, right? Go back to authority. Now the medal gives you authority, gives you credentials. So we don't care about credentials. Okay? None of that works in science. Science, you got to explain. That's science. Okay, we have the satisfaction of being able to explain, and not the satisfaction of winning a medal. This is not the Olympics where you win a medal for running faster or whatever. Okay, and censorship, we don't censor. Like they do in mathematics. You're not allowed to publish in mathematics. They run all the magazines because these magazines and journals have been around for many years now, hundreds of years, and so they don't allow anything which does not have an equation to be printed in their magazines. And that's the way they censor you. They say, no, you got to come through our mathematical method if you want to publish here. And so if you don't publish there, the public doesn't see it, because, and partly because there are translators of this mathematical world where they publish all this nonsense, all these physical interpretations, and there are people who kind of translate that for the public. And they have blogs, they have articles out there that more or less turn what this guy allegedly discovered in his office or in his lab, and they kind of translate that for the public. So they serve as intermediaries between the so-called scientists and the public, right? And so you can't get your stuff to the public. Why? Because in order to publish there, you have to put an equation. I mean, go to almost any paper out there, any paper, okay, from mathematical physics, and you won't find a single drawing. You won't find a single picture. What you'll find is just a bunch of blah, blah, and equations and words that you can't even pronounce because they've invented new concepts every day. And you won't find a single rational explanation. You won't find a single picture, because if you saw a picture, you would say, okay, I see what he's saying. He's saying this because I can see it in the picture. But they deal only with concepts. And so you won't find a physical interpretation, which they dismiss as philosophy. Okay, they say, no, you're in the wrong place, Bill. You got to go to philosophers across campus. So you go to the philosophers, okay? You go to philosophers of science. And so now you ask them, okay, look, I'd like to publish my article here. What's it about, Bill? Well, it's about how the world works, and it debunks quantum and relativity and string theory. And they say, well, we take our cues from the mathematical physicists, so you can't publish here either. So they have the whole place controlled. You can't publish. You're censored, okay? Because you're trying to give a new physical interpretation, even to the same equations, right? But they won't allow you to do that. They don't want physical interpretation. They don't want them in mathematical physics, and they don't want them in philosophy of science, etc. They don't want it at all. So you can't publish. You can't get to these people because nobody wants to hear you. Okay? So there is censorship in that sense. Now, is it censorship because it's deliberate, like there's a conspiracy? I don't think it's like that. It's more like they've got their own world, and if you don't fit in their world, they just won't allow you to publish because they're into a different world. They just want math. And so it's not like I'm saying there's a big conspiracy or anything. It's just that's the way the so-called science, mathematics, developed. Okay, so that's the starting point. So if you're in this site and you don't understand that we reject the mathematical method and we have a new scientific method which has to do with physical interpretations, with explanations, rational explanations of how Mother Nature runs her shop, okay? Unless you understand that, you're lost here. You're going to be lost here, okay? That's the first thing we got to say. So what does mathematical physics propose? Well, they do everything with this. They do everything with either particles or waves, transverse waves. Everything is mediated for the last 400 years with these two proposals. We have particles and we have transverse waves. What's the problem with it? I mean, you say, well, okay, so what's wrong with this? Okay, we have a lot of problem with this. And the first one is that the particles ain't particles. That's the first problem, okay? Particles ain't particles, not according to quantum. For the last 100 years, we have gotten rid of the corpuscle. So whenever they show you something like that, that's wrong, okay? What you're staring at is a lie, or they're misdirecting you. What you're staring at is something that's being misconstrued. You think there are little corpuscles moving at the top, right, the particles, that are moving to the side, and that's not what's happening, okay? What is a particle? We got to start there. What's a particle? Okay, and here's a particle, okay? Particle is a field, okay? That's what a particle is. Okay, so you say, what do you mean a field? Yeah, it's a vibrating field. The field is this three-dimensional spider's web that stretches all the way to infinity, or at best the edge of space-time, one of the two, whichever one you want. Okay, so that's a particle for them. And when you stop it, when you take a measurement or whatever, it looks like this. Okay, there you stopped it. Now that's a particle. Okay, and you say, well, what's all that other three-dimensional spider's web? Well, let's get rid of it so it doesn't bother your eyes, okay? This is what a particle looks like, okay? We got rid of all the other stuff so it doesn't interfere with your interpretation. That's a particle. So what they've done is they have this field, and when you have what is called a wave function collapse, okay, wave being this whole field, this wavy thingy that they never identified, just a bunch of numbers that spread out from ground zero, okay? When they take a measurement, when they put their probe there or their detector, that's when the whole thing collapses to a point. Okay, and that's their notion, okay, of what a particle is. So we're not talking about a thing. We're not talking about a little ball. We're not talking about a little bead. What they're talking about is a field, which is what? A bunch of numbers, because that's what a field is. Field is just a bunch of numbers in space, different values, different strengths of whatever, of electricity, of magnetism, of gravity, okay, just different values of that. And when you go to the center of that whole bunch of numbers, vibrating numbers, that's when you find the particle. What's a particle? It's just a function collapse. Pinpoint, no size, no radius, no nothing, no volume. But it's a value that now you can put in an equation. That's what a particle is now. So when they show you and they say, well, all these particles move, they're not talking about particles. Because when you put them against the ropes and start pummeling them and say, what is a particle? They say, well, a particle is not a particle. It's not a corpuscle. Here, you got to take math to understand what a particle is. That's what they tell you. How about the wave? Does it do any better? Well, here's the transverse wave, okay? Okay, and so what are we talking about there? Well, it's a bunch of vectors. Those blue and red arrows, those are vectors, and each one of those represents. Okay, here we have this engine arrow, and it represents, it stands in for what? Magnitude and direction. That's what you're staring at. And so what you have is magnitude and direction of a gazillions of magnitudes and direction that are moving. That's what a transverse wave is. Okay, the so-called field, the electric and magnetic fields, that's what they are. They're just a bunch of numbers that are moving. Okay, so we don't have particles, real particles, and this is what a wave is. Okay, that's what you got to live with. So we don't have a single physical object in front of us, and that's what they pretend to do physical interpretations with, at the end of which they say, well, we don't understand it either, and that's philosophy anyways. Go to the philosophers. Philosophers say, no, go to the mathematicians because they are the ones who give us the information that we're supposed to analyze. And that's it. That's what we have today. Okay, so you figure out. Okay, so let's look at, because this is the foundation I'm giving you so that you understand how we're going to get to this opacity and transparency, okay? And today I want to make clear the following. This is a mini-series. This is only the first of the series. So there's going to be a million questions. Well, how about this? How about this exception? What is that exception? There's going to be lots of exceptions. I'm going to cover them in the next couple of sessions, okay, lectures. Today I'm only going to cover one aspect, just one aspect. I'm going to show you just one aspect of what underlies opacity and transparency. Okay, let's keep that in mind. So you're going to have a million questions, and hopefully you do, because that maybe puts you to think of what other factors could be involved in opacity and transparency. Okay, so it's good that you think. So hopefully today I just get you to think. Okay, okay, so let's start here. Here we have waves. Okay. And the question with waves is, does a component of a wave, okay, in this case water wave, is that component, you know, is that the one that reaches your body? Is that the one that touches your body? I mean, if you look at waves coming from Europe to the United States or vice versa, is the little water molecule here, the one that from Europe, the one that reaches all the way to North Carolina, you know, and just waves you? Does it travel all that whole space, that whole distance? And no, you can see here that the wave is not made, the water molecule is not traveling. What it does, it kind of twirls in place. The deeper you go, the smaller the excitement, okay, of that little wave, the smaller the circle. But the wave is what continues. So we've got a difference between the wave and the water. The water stays in place, more or less, okay, it's local. Whereas the wave, whatever this wave is, verb, that moves. It's a mirage. It's like there's something moving that causes pressure, but whatever causes pressure is not something that came from over there and pushed. It's just the last few molecules that are pushing, okay? So it goes like this, you know, it's like the last few molecules are always the same ones that are pushing. It's not that the molecule from Europe hit North Carolina, okay? That's what I'm saying. And here you have another version of this, more or less, just to illustrate for you, okay? You can see that the particles are not really moving, in other words, sideways. They're just moving up and down or circulating locally, Okay? So what do we learn from this? We learn that waves, whatever waves are, Mother Nature's waves, is not traveling through. It doesn't go through. It vibrates locally, and whatever it is that's vibrating, and the wave is this mirage, this thing, this verb, okay, that you see moving. It causes pressure at the other end. You feel the pressure and you say, oh, the wave traveled. No, the wave did not travel. In other words, there is no such thing as a wave. What happened is the particles moved up and down, and that movement up and down caused pressure. The molecules that were in contact with you, those are the ones that cause pressure. And they keep causing pressure, and it's more or less the same molecules. It's not like a molecule traveled from over there and came and pushed on you. Okay? So let's keep that in mind, okay? Okay, how about sound? Does it sound any different? Air, right? And now it turns out it's the same thing. Here you have a few red particles, and you can see that we're going to think of those as oxygen molecules, O2, okay? And the particle more or less stays in place. When I talk, what you're listening is something that's vibrating the molecules close to your ears. Hopefully the molecule that's coming out of my mouth when I blow or when I make a sound or whatever vibration, hopefully that's not the one that reached all the way to your ears. Okay, what got to your ears are vibrations of the molecules close to your ears. Again, Mother Nature doesn't send particles through or waves through. She has them vibrating up and down or back and forth. Okay, and what reaches you are just the molecules that are close to you. Okay, so I just want to make sure we're understanding this part of it. Okay, here's a phonon. Okay, more or less the same thing, but it's phonon. The particle of sound. Okay, here's what the particle of sound. Okay, so the particle of sound is not really one particle that hits your ear or whatever. What it is a bunch of molecules or atoms could be that are more or less moving in situ, in place, and the whole thing waves. Okay, the whole thing waves. In other words, all the molecules, all the atoms wave as a whole. Okay, and that's what they call a phonon. Okay, they refer to this thing that you're staring at there as a phonon. So I hope you're getting the idea. The idea is that water waves, the water molecule does not travel from Europe to the coast of the United States and hits you. Okay, that's not the water molecule that hits you. The one that hits you is the last one that was there. Okay, the wave did not travel because there is no such thing as a wave. What it is, the water moved up and down more or less, right? They move sideways as well, but more or less in the same location. And what hits you is the molecules that they pushed. That's the one that causes pressure against you. Air molecules, same thing. It's the air molecules that are close to my ear that are, moving in there. There's rarefaction and compression of air molecules in there, but it's the one that are closer to my ears. The sound is moving the air here, which moves this one here, that moves that one there, and moves the one that's close to my ear. It's not that the particle, the oxygen molecule from here, went all the way to my ear. Okay, that's what I'm trying to say here. Okay, here's gravity. How does gravity work? Okay, let's find out here. So it says, let's start here. If the sun disappears, the gravitational disturbance that the results will form a wave that travels across. Okay, this is from the mathematical establishment. Okay, and it says the spatial fabric, meaning space-time, right, in much the same way that a pebble dropped in a pond makes ripples that travel across the surface of the water. Okay, so what is this about? They say that if the sun were to disappear, right, you would not feel the Earth would not feel the difference in gravity until 8 minutes later, which is the time it takes for the wave to travel. Okay, the wave has to reach from the sun to the Earth, and they claim that cannot travel faster than light, and so the fastest it can go is 8 minutes, which is the distance light would have to travel from, or the time the light would have to travel from the sun to the Earth. Okay, and so gravity at best can travel at the same speed. That means if the sun were to disappear, which is what we see there, the waves of gravity, right, that travel through space, okay, would take 8 minutes to reach the Earth, and Earth would not fly away until 8 minutes later. This is the standard version. This is what the mathematicians came up with. Okay, and so is this what's happening? Is this what the sun is doing? The sun is sending you gravity waves through the space. What is space? Well, space, they say, is made out of particles. Okay, that's what quantum mechanics proved in the lab, that space is made out of positive and negative particles. Okay, so is the sun just sending waves through this ether? or is it the ether that is vibrating and that's gravity? I mean, what's the story here? What is it that's what is this wave of gravity that's coming towards the Earth? And again, as you can see, the sun is sending these waves out. Should that push the Earth outwards? Why would it hold the Earth in place if it's pushing in one direction? Okay. And again, Mother Nature doesn't seem to work this way. Mother Nature does all these waves in situ, locally. Okay. And so if this is their notion of waves, that of gravity waves, that gravity is something that emanates and comes towards you, I don't know. That's kind of hard to believe because Mother Nature doesn't seem to do waves that way. Water waves, sound waves, light waves, maybe. Okay, how does she do light waves? Okay, here's electricity. Okay, let's find out electricity. Okay, and here they don't do it with waves. Here they do it with particles. You have the classical version, which is the electron moving from atom to atom, and I call that the classical one to distinguish it from the quantum one, which they got rid of the atom altogether. Quantum does it with electron beads. They say electricity is just a bunch of electron beads flying through space. That's what they claim today. And you can see ours is the only one that has the wave notion, in situ rotation of merged electron shells. Okay, and so ours is a wave, a true wave. It's this wave that Mother Nature uses. In other words, there's nothing traveling like in the case of the particles. It's just rotating in situ. Okay, so I just want to distinguish that. Okay, so that you can see that we have a different version. Okay, and yeah, with the quantum version, you cannot explain anything because you don't have an atom to begin with. Here's their atom, okay, and we cannot explain why that bead doesn't fly away spontaneously. That's rolling around the planetary model, and we don't know why that bead doesn't fall to the center of the atom. So we cannot justify under the quantum version why that bead just jumps back and forth between energy levels. And if you cannot justify that, then you cannot explain current, which is what they say is the flow of electron beads from atom to atom, or without atoms, just the flow of electron beads, which is essentially the quantum version today. Okay, so quantum mechanics has no explanation for anything. It has no explanation for gravity, for electricity, for water and air. I mean, are they saying something is traveling through, the wave is traveling through? Is that the version? Or are we saying that something is vibrating locally and it causes pressure, which is totally different than saying that the particle came from over there and hit me? Those are two different mechanisms. Okay, so right now quantum mechanics has this billiard ball mechanism where they just shoot balls back and forth, and Mother Nature doesn't do waves that way. Okay, that's the point I'm trying to make. Okay, keep this in mind. Okay, we're going to explain opacity and transparency with all this. Believe it or not. Okay, so here we go. Magnetism. In order for you to have magnetism, you have to align the domains somehow. Okay, and you can see they're all pointed in the same direction. Okay, so that's something you should keep in mind. Okay, that you have to align. Alignment is the key issue. Okay. Today I'm just going to talk about alignment, okay? And we're talking about going through, and we're talking about waves, okay? Waves are not going through, okay? You can't say a wave went through, okay? Wave is something, whatever that something is, vibrating in situ that causes the go through wave, okay? So this verb that goes through is not really something going through. That's where people are mistaken, okay? The thing that is waving locally, and it allows whatever to go through. And they call that whatever a wave. But there is no such thing as a wave because wave is the verb, which is the effect of those particles moving in situ. Okay, I got that through you? Okay, that's the one I want to make. So magnetism requires the alignment of domains. Alignment is one condition to get something to go through, whatever that go through is, okay? And the way we do it in the rope model, here we have two atoms bound by electromagnetic rope. That's our model. Here you have the two-dimensional atom and the three-dimensional atom. We just put the simplest atom, two hydrogen atoms there. That's more or less what they look like. Okay. Construction you'll find in some other videos that we have out there, but this is essentially the model. And with that, we're going to try to produce magnetism. And the way we produce magnetism is we have many electron shells which are merged to each other. They are aligned, which is the subject matter here. They are aligned, they rotate in place, and what they do, they swing the threads that make up the ropes and the electron shells around themselves. So the magnetic field is actually composed of threads which are swinging around the atoms. That's the invisible stuff that we cannot see between two magnets. Okay, so that's our argument. Okay, so you know where we're coming from. And here's an experiment we did with my wife the other day, and it looks more or less like this. We have two polarizing lenses, and you can see that light goes through them when they're aligned, but when they're not aligned, light does not go through the lens. It becomes opaque. Okay, so this going through stops when you just turn it around. And if light is some kind of wave, well, maybe nothing is going through. I mean, are we throwing a stone through those lenses? Is that what the photon is? A little photon that's penetrating there and going right through the glass? Is that what we're saying? And since we have gazillions of these, you know, when light hits the window, it hits every bit of your window. So we're saying gazillions of photons are hitting your window. None of them broke your window. They just went through the window. So again, the question is whether light, which is some sort of wave phenomena, is a local vibration of something rather than going through. And that's one issue. The other issue is whether you need alignment. And there you see that apparently alignment has something to do with opacity and transparency. In one direction you have transparency, in the other one you have opacity. And all we did was just realign the molecules that make up those two lenses. Okay? So how do we start this? How do we start to explain this phenomenon? Well, I do it with calcium calcite, calcium carbonate, and the molecule looks more or less like this. Okay, you have carbon, you have oxygen, and you have calcium. That's what these molecules look like. The shells, this is the shell structure of these atoms. When you put them together, they build a calcium carbonate molecule, which is the one on the right. And it's more or less like that gingerbread man there, a little calcium big head on the top. Three oxygen molecule atoms tied to the, or bounded to the carbon and also to the calcium. Okay, so that's more or less what the calcium carbonate molecule looks like. And this thing, for some reason, is transparent in one direction, but when you put it in another direction, it somehow becomes opaque. So Mother Nature, using this little molecule, one of the molecules that does polarization, is giving us a clue that something is happening to in the direction in which the molecules are pointed. Okay, and so one question you might want to ask yourself is, you know, you look at the wall, cement wall or brick wall, you can't see through it. If we were to align, okay, if we had the power of God, right, and we could align all the molecules that build your brick or your cement, would the wall be transparent? Would you be able to see through it? Because what we're doing is relaying, okay, that's the suggestion here, that's the proposal, that's what's happening when you have transparency in a polarized film, whereas when you turn the other one around, 90 degrees, no longer aligned, and so now you don't have transmission, okay, being no transmission whatsoever, being relay, okay. And so here's the mechanism, okay, I explained that the other day. Here you have one of these calcium carbonate molecules. We have these gingerbread men tied one next to each other, okay. And what we're going to do next is we're going to rotate two of these. We're going to have one behind the other, okay. So we're going to have a couple slabs of this material, okay. Here you have them. They're connected by ropes, okay. And so we have the first slab, which is made of several layers of these gingerbread men, of calcium carbonate, and you have another slab behind it. Light goes through. It's transparent. So we're saying that all these slabs are connected directly from the laser to the first slab, to the second slab, to the screen, all in a straight line. So light goes through it because it's relayed from one slab to the other. All the atoms are aligned. That's what I'm saying, okay? And when we turn them around, we rotate one of them, okay? Now what happens is they're no longer in a straight line, okay? So when you rotate one of the slabs, what you have done to the ropes, okay, is the ones that were connected in a straight line are no longer connected in a straight line, okay? So it's a question of alignment, okay? This is one of the mechanisms, okay? There could be a different mechanism as well. Let me explain that one. Give me a second here. Get this out of there. Okay, and this is the other mechanism, and that's, we have a rope, okay? And right now, remember this is torquing at great speeds, speed of light. And so this is torquing constantly, and it's got a certain frequency. What is frequency? Well, it's a certain link length. The length of a link is from where the blue starts to where the red ends, okay? We'll call that a link, okay? And so what do we have there? 1, 2, 3 links, okay? what happens when you turn one of the slabs around at 90 degrees? Well, you're torquing the rope. Okay, you're torquing the rope at a different frequency, a different wavelength, and so suddenly, you went from this to this, and so that's also happening when you turn one of the slabs at 90 degrees with respect to the other. So you have two phenomena at least that I can think of. Maybe you can come up with a third one or a fourth. Okay, that is happening when you turn one over and around. The point here is that in order to get transmission, you have to have them aligned. When you don't have them aligned, you have opacity. So you have transparency and you have opacity. Okay, so that's the point that I'm trying to make. And so these are my conclusions for for today. Remember, this is not the only. We're going to have some more stuff here, and I hope that you think about this and come up with more ideas. Okay, because I'm going to be covering them in the next couple lectures. But these are my conclusions today. Sound. It requires in situ vibrations, not travel through. Okay, water waves, in situ vibrations. There's nothing traveling through. Okay, which is the quantum version. Okay, gravity waves don't travel through. Okay, here you had. I mean, what is waving? Is it the ether? Is it space made of particles? Is that what's waving up and down? Or is space there, just sitting there, whether it's a bunch of particles or nothing, whatever you choose, and you have this wave from the sun just come out and reach you? And you might say, well, that's what the sun does. It sends us electromagnetic waves. So does it also send us gravity waves in the same way? Some thing that we can't see, because we can see the light you can see, it hits you, it tans you, right? And so how about the gravity? Is it sending you a gravity wave? What is this gravity wave that is sending you? Is it also a transverse wave? So again, gravity is not traveling through. Okay, so going through. This is the notion you have to get rid of, this traveling and going through. Electricity. Is it particles going from atom to atom? Are the electron beads going through the film or whatever iron or whatever your wire is made of? Or are they twirling in place? Okay, is the wave of electricity something that twirls in place, or is a little bead really going from negative pole to positive pole? Is it traveling all that at the speed of light? Okay, so this is what we got to look at. Magnetism. You have to align the domains. If you don't align the domains, you have a chunk of iron. You want that iron to pick up something magnetically, you have to align the domains. Then it becomes a magnet. Okay, so alignment. Polarization. Here you have alignment. And here you have disalignment. Okay, you don't have alignment when you turn one of them 90 degrees. And suddenly we went from transparent to opaque. Okay, so that should make you stop and think that maybe Mother Nature, one of the mechanisms she uses is the alignment of molecules. Alignment, and it gives us something about the nature of light. It has a wave nature, but the way Mother Nature does waves is not by sending through, but by doing something in situ. Whatever's there is moving, spiraling in situ, locally. Okay, and of course with a rope you can explain that. Rope is in situ twirling. Okay, each one of those links is what the mathematicians confuse for photons, and they think that the photons are traveling when what's happening is really something is twirling in place. Okay, so that's the first installment. Okay, the first installment is that alignment is necessary to do waves and to do transmission. And if you don't have alignment, you have opacity. Okay, that's the first installment. We'll go with the other things that Mother Nature uses in the next couple sessions.